Okay, well, hello and good afternoon, everyone. Welcome to the What Does Climate Change Mean for Indiana webinar. My name is George Bergstrom, and I am the Southwest Regional Coordinator from the Indiana State Library's Professional Development Office. I'll be host and question moderator today. Our presenter this afternoon is Melissa Widhelm, Operations Manager at the Purdue Climate Change Research Center. I'd like to start off the webinar with a few announcements. To register for other webinars and other trainings available from the Professional Development Office, please see the Indiana State Library's events calendar, which can be found on our website at www.in.gov/library. The session is an hour, so you will get one LEU for today. If you're watching the archived recording of this webinar, the instructions on how to obtain your LEU are available in the video description on YouTube. Or you can also find these instructions on the Indiana State Library's continuing education site under LEU policies. Without further ado, I will now turn the presentation over to Melissa.
Well, thank you. You hear me okay?
Yes.
All right, great. So, hello, my name is Melissa Widhelm. I am the operations manager for the Purdue Climate Change Research Center, and it truly is my pleasure to be here today to talk about this question that you see here on the screen. What does climate change mean for Indiana? Now, today I'm joining you from my home in West Lafayette, Indiana. And when we're not dealing with a global pandemic, you can find me on Purdue University's main campus. One of my primary responsibilities at Purdue is overseeing the development of the Indiana Climate Change Impacts Assessment, which I'll tell you quite a bit more about in just a little bit. My academic training is actually in the fields of meteorology and climatology. And over the last decade, I've spent much of my time on projects like the impacts assessment that really aim to make climate information more usable to people throughout the Midwest. Let's see. All right, so just to help orient everyone today, we're going to spend about half of our time looking at the science of behind climate change. So we'll talk about what is driving global warming. We'll take a look at what the observations show us about past climate trends, and we'll take a look at some of the future projections that our scientists right here in our great state of Indiana are telling us to anticipate. Then we're going to go ahead with the remaining time and dabble a little bit on the topic of data perceptions to really help us better understand how people's perception of climate change does or does not align with the scientific conclusions and why that is. That's actually pretty important. So I'm looking forward to that part. And then finally, I want to provide just a little bit of information on what's happening here in our state to help improve climate change literacy and education, and to help support climate conversations throughout the state. My goal is to leave about 10 minutes or so at the end for questions and discussion. So as I'm working through these topics, if you have a question, be sure to jot it down in the chat and we'll try to get to that. And I'll also be providing my contact information at the end. If we don't get to anything, I am here as a resource for you. I encourage everybody to please be in contact to follow up. All right, so sorry, I keep hitting my arrow key, but I need to click. There we go. So before we jump into talking about climate change right here in Indiana at this really local scale, let's first start out by zooming way out for just a little bit of perspective. And I mean zoom way out, like right here, looking into outer space at these two illustrations of our world with these two colored balls on top of them. So I like to start here just to demonstrate what we're talking about in terms of scale and fragility of our environment. So on the left side, this earth with the blue marble on top, that blue marble, that's actually representing the total volume of water on Earth. So all of it, if you took water from down deep in the ocean, in the ice caps, our bodies, rivers, lakes, streams, the atmosphere, everything, crammed it together, it would fill a ball about the size of that blue one there on the left side of the screen. So it's an amazingly thin layer when we look at our water like this. So if we flip over to the right side, that pink ball, that's actually representing Earth's atmosphere. So if you took all of the air from the surface of the Earth up to the top of the sky, all the way around the world, you crammed it together, it would fill a balloon the size of that pink ball right there. Okay, so again, it's also a very thin layer. Now, think about it. We're all breathing and flying and driving and running our factories inside this little pink balloon. Okay, all 7 billion of us on this planet. Now, when we look at the atmosphere in this way, it's a lot easier to start to understand that we could really be having an impact on the concentration and the types of the gases that make up our atmosphere. And in fact, we have been. All of that flying, sorry, it won't advance here for me. There we go. All of that flying and driving and energy generation has actually converted billions of tons of fossil fuels like oil and coal and natural gas into carbon dioxide. And as we put carbon dioxide into the atmosphere, that concentration of that gas, the amount of it in our atmosphere increases. In fact, since the start of the Industrial Revolution, we've actually increased the concentration of this gas by about 50%. So what we're looking at here on the screen in red, that red line is showing us the concentration of carbon dioxide over the last 130 years or so. So as you move across the right side, from left to right, you're going through time. As you go up and down, that's showing more carbon dioxide as you go up, less as you go down. So if you follow that red line, you can see that carbon dioxide levels have been on the rise. That white line is actually showing us the year-to-year change in global temperature compared to a long-term average. So we call that a temperature anomaly. How much warmer or colder is it compared to some baseline value? And so what we see here, year to year, it kind of shifts up and down a little bit, but over time, we see this warming trend. And so as you can see just how closely carbon dioxide and temperature track one another. Now, oftentimes people will say, okay, well, this only goes back 130 years. What if we go really far back in time, like really, really far back? Well, let me put that into perspective for you. Honestly, for hundreds of thousands of years, concentrations of CO2 have never been above 300 parts per million. Okay, so what we're showing here on this graph, the far right side, 1880, that's where our previous graph started. If you move to the left, you're going back in time. And so we're talking about using records from ice cores and tree rings and sand cores down in the ocean and all of these other pieces of information that scientists have perfected the ability to extract information about our atmosphere. We can put together this incredible record. And so as we go back in time from right to left, we see that carbon dioxide concentrations in the last 800,000 years had never been above 300 parts per million until now. And so I added a little bit of context here. This box that I just popped up on the screen, that's the time period of the last graph I showed you from 1880 to current day. I just put some markers here on the graph, 1960 and today. So the bottom line is that we are in uncharted territory here, not only with the amount of carbon dioxide in our atmosphere, but also with how rapidly we are increasing that gas. Okay, something that would previously take tens of thousands of years to change in that amount, we are doing it in the matter of decades. So how does this warming effect actually work? What is the mechanism behind this? This is often a question that comes up with students and even with adults, and there's a lot of confusion on just the basic physics here. So let me give you the really basic overview because this is really important. Carbon dioxide is what we call a greenhouse gas or a heat trapping gas. And greenhouse gases are those molecules that have the unique ability to let light from the sun pass right through the earth and warm up the earth. But as the earth starts to radiate heat out to space, those greenhouse gases block that heat from escaping. So you can think of it like a giant clear blanket wrapped around the earth. And as we burn oil and coal and natural gas to power our modern lifestyle, it's like adding another blanket when we're already perfectly warm. Okay, so we need this greenhouse effect to keep our planet at the right temperature. This is a natural process. But as we burn coal and oil and natural gas, we are enhancing that greenhouse effect, okay? We're having an impact on it. And so this is not actually a new concept. We've been talking about it a lot in the last few decades, but really physicists discovered this connection between burning fossil fuels and Earth's temperature warming way back in the 1800s. So it's something that we've had a pretty good handle on for quite a long time. All right, so let's look at this in another way. For each year from the late 1800s to 2014, this graph is showing us how much above or below Earth's global temperature has been. So if you think back to a couple slides ago, that white line that was kind of jumping up and down and moving up over time, that's what we're showing here, okay? Global temperatures, how much warmer or colder have they been compared to the 20th century average? And what we can see is that temperatures are on a rapid upward trajectory as concentrations of greenhouse gases increase. Okay, in fact, the 10 warmest years on record have all happened since 2005. Now, when this graphic was developed, we had set a record with 2014 being warmer than we had ever measured. But it was short-lived because it happened in 2015, it happened again in 2016, and the trend has continued. And currently we are, last year marked our 44th consecutive year of temperatures being above that long-term average. Okay, it was the second warmest on record. Okay, so this is the scale of what we're talking about here. This is the type of warming that's happening. All right, so a few degrees of change, I understand that might sound pretty small, but remember, we're talking about the climate, not the weather. So the weather is a snapshot of what's happening at a certain place at a certain time, and really it can swing wildly from day to day to season. When we're talking about our climate, on the other hand, that's the long-term average of conditions over a period of time. And so I like to think about the climate like our body temperature, okay? When we're talking about the long-term temperature of the Earth, it's very similar to our bodies. It's very, very stable. It's moving up or down by just a few tenths of a degree when we average it over the course of a year. And so scientists really like to look at average temperature because of that stability and because of how sensitive, how much it is stable. It doesn't move very much from year to year. Well, that also means that when we start talking about a full degree or 2 or 3 of warming in that long-term record, it's actually a pretty big deal, and it translates to some pretty dramatic impacts on our local weather patterns. And so as the Earth warms, we're seeing alarming trends in key environmental indicators worldwide. If we look at our long-term measurements going back, 100 plus years, scientists can tell us with certainty that, say, the wildfire season out in Western US has been getting longer and more intense. We know that the extent of Arctic sea ice is dwindling. It's declining at about a rate of 13% per decade. We can look at these records and see that when Glacier National Park was founded in 1910, there were 150 active glaciers. Do you know how many exist today? Just 25. 25 glaciers remain. So these observations show us that our climate is a complex, interconnected system. As we change one part of the system, it's going to have rippling effects on another part, and that this problem goes beyond warming temperatures alone. Now, here in the US, we are actually very fortunate to have rich and robust data that's being collected by many, many different groups across the US and across the globe, really. So we have 13 federal agencies actually that coordinate together in what's called the US Global Change Research Program. Many people don't realize we have this. And is mandated by law about every 4 years or so, going back to 1990. This body puts together a thorough peer-reviewed assessment of the state of our climate. All right. And in the interim, they put together some special topic reports. I put up a few recent ones here on the screen in case you're interested in those or you want to consult those. It certainly is the authority on our national climate, and it is a highly trusted and respected source of scientific information here and abroad. And so if you're interested, you can go visit globalchange.gov to find all of these reports. and to dig more into this national view from this scientific body. All right, so back to the data. We've been talking about shifts and key indicators in faraway places, but I want to talk about Indiana. All right, we spent enough time looking elsewhere. Our scientists are actually measuring and monitoring changing weather patterns right here at home. Okay, this isn't just something that's happening at faraway places. Um, you see it in our temperature record. Our temperature record shows that Indiana has warmed about 1.3 degrees over the last 125 years. Remember, that's the climate, not the weather. And with this 1.3 degrees of warming, we are seeing shifts in our frost-free season. So that period of the year when we are staying above freezing and things are growing, and it's actually my favorite time of year. And it's about 2 to 3 weeks longer than it was 50 years ago. On average, we see fewer cold days, extreme cold days. We are a northern climate. Winter is not gone. It's not going away, but it's different than it used to be. All right. And our overnight temperatures, you see significant warming in our overnight temperatures, really at about twice the pace of our average. So you see these changes locally in temperature, you see them in rainfall. I would argue you see more dramatic changes in our rainfall than anything else. We're showing in the data, we get about 6.5 inches more rainfall annually today than we did 125 years ago. And what I'm showing on this map, if we look at it by region, we see that all parts of the state have been getting more rain, but it's really that southern part of the state that's seeing the most rapid increases. We have places that have seen over 8 inches more annual rainfall on average compared to 125 years ago. So that is a lot of water to deal with. But it's not just that we're seeing more total rain, okay? That's one part of the story. But when we look at the data, we also see that heavy rainfall is more intense and happening more often. Not just here in Indiana, it's happening throughout all of the Midwest. We have research too that looks at specific weather stations in Indiana, and we see a growing number each year of 2-inch events, 3-inch events, 4-inch events. So if you feel like those heavy rainfall events have becoming stronger, more frequent, your perceptions match the data. And as our total rainfall increases, as our heavy downpours increase, that leads to higher stream flows, and that leads to a greater risk of flooding. We've seen this. This is happening. So again, this is not just an issue for distant points at the future or for faraway places. Okay, we have multiple lines of evidence that show us our climate is changing right now, right here in Indiana. Okay, it affects our families, it affects our businesses, it affects our communities, it touches all of our lives. And so, given the changes that we've already measured, a valid question that comes up is what should we expect for the future, right? Should we expect this to continue? If so, what are those impacts that we need to be anticipating here at home as things continue to change worldwide? And so these are the types of questions that our faculty at the Purdue Climate Change Research Center have been asking for quite some time. So the PCCRC, Purdue Climate Change Research Center, it is a faculty-led center at Purdue that's really working to understand the impacts of a changing climate and also to develop novel solutions that help people reduce those carbon emissions and also help them prepare for current and future impacts. We've been around a little while. We were established in 2004, and we actually have over 90 affiliated faculty across campus working on a broad range of subject areas related to climate change. In keeping with our land-grant university mission, our faculty are engaged in research and in teaching and in outreach. And so that means we really strive to be a trusted source of information, not just for people here in Indiana, but beyond our state as well. Now, one way that our center is working to answer this question of what does climate change mean for Indiana is with the Indiana Climate Change Impacts Assessment. So I mentioned that earlier. That's one of the projects that I help coordinate here at Purdue. And this Purdue-led effort actually involves about 100 collaborators in a voluntary voluntary statewide effort to assess what climate change means for state and local interests. And one of the primary outcomes from this collaborative work is a series of plain language reports on the topics you see here on the screen. To date, we've made 8 reports available. We started rolling them out in 2018. We have a couple left to do. The pandemic set us back a little bit, but we're still working on those. And I encourage you to go to our website, indianaclimate.org, and check out the reports. When you go to indianaclimate.org, that'll actually redirect you to a Purdue University website where you'll find all of this information that I'm sharing here today, plus more. We don't have enough time to even really dive into any, with any depth into these key findings, but there are some big picture takeaways that I think are really important to review with the remaining time that we have. So let's just jump right in. The first big takeaway probably isn't very surprising to people. The first big takeaway is that Indiana is going to be getting warmer, okay? But a lot warmer. What I'm showing here on the screen is a look at Indiana's statewide average temperature in the past, okay? So from 1900 until just the last few years. And so remember that 1.3 degrees of warming that I was talking about? That's represented by the black line there. That orange line that kind of goes up and down, that's showing each year if you're warmer or colder than the average. And then again, that black line is that long-term trend. So this is what's been happening in the past. If we move to the right side of this graphic, now future temperatures are being projected. And so for the Indiana assessment, we actually used 10 different climate models to look at a range of possible future outcomes with some very clear patterns that emerge. And so this red area on the screen, that is showing us an assumption of temperatures if our heat trapping gas emissions, those carbon and other greenhouse gas emissions, kind of continue as they are right now. We're not really doing anything too dramatically to really make an impact on those. That lands us somewhere in this red area. This green area, on the other hand, that reflects the range of temperatures if globally we were to act pretty aggressively and pretty quickly to reduce our carbon emissions. And so based on the best available computer simulations, our scientists right here in Indiana have concluded that our state's average temperature is expected to warm about 5 to 6 degrees Fahrenheit by the middle of this century. Okay, that is a tremendous amount of warming. And if we go out even further towards the end of the century, we're talking up to 10 degrees Fahrenheit of warming. But even just focusing on that mid-range, 5 to 6 degrees of warming, really that depends on how much we do or don't slow the emissions of those heat trapping gases. Now, before we move on from this, there are 3 important takeaway messages that I want to specifically point out. The first one is that you'll notice that we expect the warming trend that we've detected over the last century not just to continue, but to accelerate, okay? So this is because that primary driving force, those heat trapping gases, carbon dioxide, it is long lived in our atmosphere. And so as you add to it, it becomes more intensified and it takes a long time for it to dissipate. We're talking hundreds of years once you put it into the atmosphere that it sticks around. So not only will the warming continue, but we expect it to accelerate. The second important message is that based on the amount of heat trapping gas already in the atmosphere, based on that amount, even if we were to quit emitting today, we're still going to see some warming. Okay, so I put a box around these upcoming decades, and you'll see that green and that red area are pretty close on top of one another. All right, so that's showing us that we need to be preparing for the changes that are already underway. Okay, it's like a moving train. Even if you pump the brakes right now, we still have that momentum carrying us forward. Okay, so we need to be preparing for that amount of warming that's already baked into the system. The third key message is that we have a choice in our future, okay? We have a choice in where we end up, but we have to act pretty urgently if we want to avoid the most significant amount of warming, Okay, so it's really after the 2050s when these two paths start to diverge. And there are two very different futures, being in that green area and being in that red area. Okay, so temperatures in Indiana are going to be getting warmer. With those warming temperatures, you're going to see more extremes, more extreme heat, less extreme cold. You're going to see shifts in your seasonal temperatures. Another key message, though, is related to water, and that is that water is going to be a problem. So if we're looking at our annual rainfall, we're kind of looking at about 6 to 8% increase. And I mean, we're Midwesterners, we deal with a lot of rain. Maybe 6 to 8% doesn't seem like a lot. But you have to remember, it's not going to be evenly sprinkled throughout the year, right? That doesn't mean it's going to come in these little manageable batches. If we look at how we expect these shifts to happen seasonally, we see a significant increase in the winter and spring, which is the time of the year when we're already prone to flooding. And frankly, we don't need more water. But we're expecting to see some modest declines at times of year when we do. Okay, when we need water for drinking supplies, for crops, for wildlife, for all of the things that demand water, especially when it's hot. Okay, so you talk about these remaining at about our current level or declining slightly in the summer and fall. You add in that heat, we're talking about water stress, water shortages, right? Water is going to be a problem. And so if we want to be more resilient, we're going to need to figure out how do we manage for times of too much and too little, and often in the same season. Now, as we're thinking about these overall changes in temperature and precipitation, we also have to remember we've built our society around a certain set of climate expectations. And so when we start changing one variable or another, we're going to see cascading far-reaching impacts. Okay, and that's another key takeaway from our assessment. We will have cascading far-reaching impacts that are going to touch all aspects of our lives. So there are a ton of examples. Pretty much all of the impact assessment reports focus on these impact pathways. How does a change in one climate variable lead to changes in other parts of our environment, our society? Let me just walk you through a few of them to try to really paint this picture of what we're talking about here with cascading far-reaching effects. This one is probably one of the most common ones we talk about. It affects so many different things. Let's think about what happens when we dramatically increase rainfall in the spring. Okay, that's saturating our soils at a time of the year when we don't have very many crops in the ground. We don't have a very high demand of water. And so the rain comes, saturates the soil, not much use of it yet in the soil. And so on our ag fields, we get these drain pipes that we install. You can see a picture of them here. A wonderful technology that has helped us become so productive, right? Draining off those fields when we don't need all that excess water. So what we're expecting is that we're going to see quite a bit of increase of this rain flowing, this water flowing out of these drain pipes. If you're just looking at central Indiana, we're talking about a 29 to 47% increase in the amount of water coming out of those pipes in the spring. Okay, so what does that mean? Well, it certainly means we're going to need to be upgrading our infrastructure, our drainage infrastructure to handle these types of flows. It has implications for water quality. As you have water pulling through the soil, pulling out nutrients, depositing them in our waterway, that has implications for water quality. What about flood control? If the folks downstream also have an increased abundance of rainfall, where is that water going to go? Okay, it has to have somewhere to go. And so it starts to create flood control issues when we don't have anywhere to put that water. And all of this is in addition to those direct impacts facing farmers with delayed field work, right? If it's soggy, you can't get out there to plant in time. You're talking about soil erosion, right? As that water sits on there, moves across the land, erodes away that soil, that reduces yields. That has financial implications. So this is what I'm talking about when I say cascading far-reaching impacts. We can see it too with our health threats. So when we have shifts in our temperature and precipitation, health and climate really intersect. So if we have more heat, right, if we have higher temperatures, more heat waves, we're very naturally going to have more heat related injuries and deaths. When you increase the temperature, air quality goes down, right? You get ground level ozone that is created, especially in our more populated cities, and that creates significant breathing issues for people with asthma or chronic disease. When we have a longer growing season with our plants, we have a longer allergy season. Pollen season is more intense. That is a huge impact on a person's quality of life. I have family members who deal very severely with seasonal allergies, and just thinking about an extra month of dealing with that is really life altering. More pests and disease. If we're talking about more rainfall, warmer winter temperatures, you're not kicking back those tick populations. You're increasing those mosquito populations and the types of mosquitoes, right? Those can carry disease, those can have health implications. Even something as simple as, more flooding events. Well, when a house floods out, if they haven't been able to properly dry it, now we're talking about mold. Now we're talking about our physical bodies being in the way of floodwaters, right? You can start to see these impact pathways, how you go from having an impact, a change in your climate, to a significant effect on your personal self, on your day-to-day life. Here's one last example of these cascading effects. I took this one from our tourism report, which says that climate change is going to affect the timing, enjoyment, and safety of outdoor activities. And that affects not just the visitors doing those things, but the businesses and the communities serving the tourism industry too. So again, if we're talking about increased heat, what does that mean for land-based activities or sporting events, right? I have a little one who's plays Little League, and I think of him out there in his catcher's gear in 100-degree weather, and it's maybe 3 or 4 times a year. What if it's the whole month, right? That changes how we have to do things. That changes how we schedule our recreation or the safety of it, right? Heat exhaustion is a huge concern already in our climate. Increase that temperature and it's going to become more severe. Same thing with auto racing, right? We've had major car races already change the time of year they run their race because they're trying to avoid the heat. Right? These are things already happening. We didn't really talk about crop production today, but we expect lost yield potential and reduced food quality here in Indiana. So if you have a U-pick farm or other agritourism business, you're going to be affected. And that's in addition to these large scale farming operations. So again, there's these seemingly endless ways that we have negative effects on the timing, enjoyment, and safety of our outdoor recreation and tourism. Whew, okay, I have given us a lot of information. We're only halfway through. Can you believe it? I know I've given you a lot to think about already. We've barely scratched the surface on these impacts on this climate science piece. So I really encourage you to check out indianaclimate.org, go through the rest of the reports, see what else is out there. In the meantime, I'll give you the 45-second recap before we move on with the rest of our program here this afternoon. So historical observations show us that we are getting warmer and we are getting wetter. And the best available science tells us that these are going to continue and intensify. In the coming decades, we're going to see growing challenges related to extreme heat and related to heavy rainfall. And if we're going to effectively manage these climate and these water risks, we have to be thinking seasonally in addition to annually, right? There's some pretty significant seasonal shifts underway. And really, I can't say this enough, those impacts are far reaching. They affect all of us. But let's not forget, where we end up depends on the choices we make, right? How vulnerable are our communities? How able are they to withstand some of these impacts? Are there things we can do to be more prepared to reduce the severity of these impacts or to cut down emissions and reduce the overall amount of warming, right? We have a lot of choice here. We have a lot of control here. So it feels doom and gloom, but there are things that we can do to make a difference. Okay, so now that we've explored our past climate trends and our future climate projections, let's move on to looking at data perceptions and some things that we're doing to improve climate literacy here in our state. So we just spent quite a bit of time looking at that best available information from the scientific community, not just in the US, but here in Indiana and across the world. And based on that, there's overwhelming scientific agreement that our climate is changing and that human activities are driving those changes. That's the scientific conclusion supported by over 18 scientific societies in the US, such as the American Medical Association, the National Academies of Sciences. And that's the conclusion supported by over 97% of actively publishing climate scientists. Okay, our climate is changing and human activities are driving those changes. However, based on a 2020 survey of US adults, which is conducted by Yale University, it happens annually, so we have these data going back pretty far, we see that just 72% of US adults think that global warming is happening. I should note that's up 5 points compared to a year ago. But when we look at if you think it's mostly due to human activities, just 57% feel that way. If we switch over from US adults to Hoosier adults, we see those numbers drop even more. So let me do that again. So in the US, 72% think global warming is happening, 57% think it's mostly due to human activities. Here in Indiana, that's 64% think global warming is happening, 51% think it's due to human activities. When we ask people if they think that most scientists believe global warming is happening, just 55% agree. And in Indiana, that's just 48%. Okay, so that means there's a large part of the population that doesn't think there is a scientific consensus on global warming, even though the published literature shows nearly 100% of climate scientists are in agreement. All right, so if we look here, about 54% of Hoosiers say they are worried about global warming. Just 35% think that it'll harm them personally. This is sometimes what I call the polar bear problem, where people think climate change is an issue for faraway places or distant times in the future. And it's actually, in reality, a problem for us right now, right? As we just learned about with the Indiana assessment, climate change is already happening, and it's affecting the heartland. All right, and these consequences are real. So there's clearly a mismatch between people's perceptions and the evidence-based conclusions about climate change from the scientific community. And this matters a lot, okay? It affects if and how we talk about issues. It affects how we plan for risks. It affects how we fund and implement solutions, even which solutions ever make it to the negotiating table, okay? So what is driving this mismatch? Why is there so much denial and misinformation about climate change? Honestly, this is a huge topic. This alone could be an hour-long discussion. So we're just going to kind of skim the top at some of these big reasons that are pretty important and some pretty surprising things that have come out from the research over recent years about climate change denial and misinformation. One of the first reasons that often comes to mind when people think about this mismatch is that it's a knowledge gap. If people, specifically adults, just knew the facts and had the data, they would see it, right? They'd know. They'd change their opinion on it, right? Well, not so much. There's actually research that is found for US adults. There's really no correlation between their level of science literacy and their views on human-caused global warming. And again, this is for US adults as a whole. Rather, studies show that the strongest predictor of a person's climate change belief is actually their political affiliation. Oh, so, right, that's just a testament to how highly politicized this issue has been. And as a result, I put this is one of the main researchers working in this area, Dan Kahan from Yale. He says, what you believe about climate change doesn't reflect what you know, it expresses who you are. So people are put in this position of us versus them, right? They're taking sides. And it's either the scientific community or their own personal community. And if their own personal community is misaligned with the scientific community, that can have some really real consequences in a person's life and their social circle if they step out of that, right? That's a real thing. So as a society, we're assigning these toxic cultural meanings behind climate change beliefs. And where you stand on an issue is used as like a badge of honor, a signal to what group you belong with. And that really makes it difficult to remedy this mismatch between the data and people's perceptions. So that's one thing that's going on. Another thing that's going on is that, climate change is a complex, slow moving problem. And just the way our brains are wired, that really feels too big to process for a lot of people. We go into self preservation mode where denial is a coping mechanism, right? We might not even be consciously thinking about it. But think about what the science are telling us. Think about the scale of both the problem and the solutions, right? That feels terribly overwhelming. This emotional response that people have to traumatic information is really overlooked. People, it's quite common for them to react to disheartening information about climate change with feelings of fear or guilt or anger. And all of these can put someone on a path to denial. And so it's not just about the facts, right? It's how we feel about these facts that can drive our position and drive our responses. And honestly, I don't think we talk enough in scientific community about this side of it. Okay, this one gets a little bit uncomfortable. This is the last one I'll touch on related to this mismatch in information. When it comes to climate change, misinformation abounds, and it is not by accident. For decades, there has been a shocking amount of money that is being spent on raising doubt and mistrust in climate science. And so it's very similar to some of the misinformation tactics that were used decades ago in the tobacco industry. And so they aggressively spread false claims about the health and safety benefits of smoking, despite the fact there was strong scientific evidence that showed smoking was dangerous, right? And that took years to overcome, right? This misinformation. And so when we think about it from climate change, it's really people or groups that are threatened by a shift in the status quo, who are benefiting by activating and maintaining this information, this misinformation. And so in terms of climate change, we're talking about who's benefiting from a carbon intensive economy, who stands to lose money, status, or power if we shift away, right? So misinformation actually takes many forms. Sometimes it's very subtle and sometimes it's very blatant. Let me give you just one example of what this might look like in action. Ahead of the 2017 school semester, this book that I put up here, that the cover on the screen, Why Scientists Disagree About Global Warming, this was physically mailed to virtually every public K through 12 science teacher in the nation. This was mailed to private school teachers. This was mailed to college educators. This book is part of a series, a whole series of books that refutes climate change. And it was developed by the Heartland Institute, which is a bit controversial think tank that has received millions of dollars in funding from interest groups with ties back to fossil fuel industry. So this was a very large, very well coordinated effort to sow doubt in the scientific facts and keeping that larger conversation on the validity of the climate science, as opposed to putting that conversation into the solutions part. What do we do about this? How do we solve this problem? Okay. As a result of these efforts to sow doubt and misinformation for literally decades, we're finding headlines like I put up here on the screen on a more regular basis. Okay. Teachers here in Indiana, teachers around the country, they are struggling to find credible materials on climate change. And it's not just online materials. Okay. A recent review of dozens of middle and high school textbooks found superficial and inaccurate descriptions of climate change. Some of them don't discuss it at all. So this is just one of several studies in recent years showing there is a systemic problem with how climate change is being discussed in textbooks in the United States. Now, even under the best circumstances, teaching about climate change is just plain hard. Okay. It is an interdisciplinary topic. It requires students to analyze scientific data and models. Learning is often influenced by your prior knowledge, and we really lack a well-developed conceptual framework and learning progression on this topic. And so with it being such a large topic area too, many teachers don't even know where to begin, right? We don't have an endless amount of time and capacity in our classrooms. Where do I even begin? How do I even start getting this in to my work? So to help with this problem, in 2019, a couple of Purdue faculty who spent years researching best practices for teaching and learning about climate change published an article in the magazine American Educator based on all of their research that outlines 5 critical topics about climate change that every student should know and that every adult should understand. And the idea was to identify the most important topics that would help students develop a deep, rich understanding of the fundamental concepts of climate change, therefore enhancing their potential for future learning. And so we have this as a poster on our website at purdue.edu/climate. I should have put the QR code to scan that here on the screen. My apologies for that. But the 5 basic topic areas, the first one's really weather, climate, and climate change, right? Students needing to fundamentally understand the difference between weather and climate. That's a huge misperception on a really hot day or a really cold day. Oh, there goes the theory of global warming. Like, no, we're talking about weather, not climate, right? There's a difference. Students need to know that. Earth's climate system, right? Understanding that we have these complex interconnected feedbacks that go beyond just simple cause and effect, okay? There's a lot of interaction between these systems of atmosphere, ocean, land, vegetation, ice. Students need to understand that and really start to represent how, in their minds, how changes in one system have these complex rippling effects in other systems. The third has to do with the Earth's energy budget and the greenhouse effect. We talked about it a little bit at the beginning. If we look at mental models of how students conceptualize the greenhouse effect, they're often very inaccurate. And that matters to how we understand the climate system, how we build solutions, how we prepare our workforce to be addressing these problems, right? We need to have that fundamental understanding. The carbon cycle more broadly, how carbon moves through Earth systems and how the human component really enhances that carbon cycle. And finally, the 5th topic is really teaching on the scientific perspectives of climate change. And so needing to teach to that, needing to see that the debate and controversy lie in the social, economic, and political approaches to address global warming, not in the actual physical science itself. And so these are these 5 critical topics that our faculty have come up with that are essential starting points for setting students on this potential for longer term learning. Now, if we compare these critical topics with Indiana's academic standards for science, looking at grades 6 through 12, we see that by and large, foundational climate change concepts are absent, okay? This makes it really challenging for educators to integrate these concepts into classroom curriculum. It also is really a disservice to our students who are missing out on this foundational information for an issue that's really of global significance, right? Not just for being an informed citizen, but being a productive member of our future workforce. Now, because of this, these gaps in the Indiana academic standards related to climate change, last year we partnered with the Indiana Department of Education and with several Indiana teachers to develop what's called the Indiana Climate Change Education Framework. This project was actually initiated by the Department of Education last fall, and the end product was a searchable database that provides access to curated climate change resources that are aligned with both the 5 critical topics and Indiana academic standards. Okay, so we were able to go through, and even though we don't have standards on climate change, there are topics on climate change that can align with standards. And so we've sorted through all of those, and we think this will help educators integrate concepts into their existing work as opposed to expecting them to go above and beyond teaching contents beyond those standards, right? That can be really difficult. Again, we're time limited. We don't have an endless amount of leeway of what additional topics we can cover when we also need to be covering the standards. So that's what this database does. You can scan that QR code to open up our landing page for that project, or you can type in the URL at the bottom of the screen, or send me an email and I can send you to that as well. Additionally, the PCCRC at Purdue, we partner with a lot of people and groups at Purdue to offer professional development to Indiana teachers. So specifically focusing on helping them strengthen their own knowledge of climate science and to provide guidance for on techniques for talking about climate change and teaching about climate change. And so we had a National Science Foundation grant many, many years ago that developed this Dynamics of Climate workshop. It was a 2.5-day training for educators. We've held several of them. Funding ran out for that project, and then the pandemic hit. And so we've actually converted it into a 1-day virtual event. We just did one a couple of weeks ago. We'll have another one in the fall. And again, it's really trying to focus on the teacher getting that more in-depth training on these fundamentals of climate science and give them some very specific techniques for integrating that into their classroom. And we have a couple of other new professional development trainings that we're working on for next year as well. And finally, we offer a number of passive resources that are specifically focused on Indiana's changing climate. And this is useful for both formal and informal educators. And these can be accessed through the Indiana Climate Change Impacts Assessment website, which is indianaclimate.org. And so I hope that some of this information was interesting, useful. I invite you to stay informed and connected with us. We have a monthly newsletter for the impacts assessment. So if you're interested in that, you can send me an email. It's there on the screen, mwidhelm@purdue.edu. Like I said before, we are a resource for you. It is part of our mission at Purdue University to do that. And it looks like we have about 9 minutes left. So I did a pretty good job staying on track there. I have not been able to monitor the chat as we've been going through, but perhaps George can help facilitate us through some of these Q&As. And so with that, I'll just say thank you so much for your time and attention today.
Yes, thank you. We do have at least 2 that I've taken note of. So if there are any other questions, go ahead and start typing those in now. But the first one is, and if you know it, great. If not, maybe you can point us in the right direction, was about the Yale survey and sort of questioning what the other percentage of people who don't attribute it to human causes might believe, or if you don't know that, obviously, if you knew the question, the specific question that was asked. I think we have someone who's pretty good on surveys, maybe, who understands the question asked could impact.
Absolutely. So the nice thing with the Yale group, they provide all of their question sets, how they asked it, what specifically they asked about, all on their website. And so I don't have those, since I wasn't involved in those, I can't give you those off the top of my head, but I can tell you if you just Google Yale climate opinion maps, you will land on their page and they have all sorts of metadata and methods and all of that. We do have work that is more specific to Indiana that happened through the Indiana University Environmental Resilience Institute. We also have some work out of Purdue a few years back that looked more specifically at climate opinions on farmers, farm advisors, and extension professionals. So there's a lot of different ways to slice and dice it. But yeah, oftentimes people will think that it's either a mix of natural and human causes. Generally about, a quarter to a third of people will say, it's natural or it's not happening at all. And so there's really a mix. And what I like about the Yale information, even though, their methods are different than say what the IU methods were, when you start converging on, topics asked in different ways maybe to slightly different populations, but they all kind of fall in that same general area. You can get a range of where the public opinion lies. I mean, they're not that much different in terms of the final numbers when you look across surveys. And so I feel like we have a pretty good handle on people's opinions there. But what's really useful with the Yale one is that we do have that information over the last decade, right? We have it every year going back in time. And so we can see how things have or haven't moved on all of these different questions. And they talk about, one of the things I like too is they talk about people's opinions on solutions. Like, should we be teaching this in schools? Is it the local government responsibility? Is it responsibility of individuals? Should we have, um, you know, energy efficiency requirements? And, they ask all these different questions. So I encourage you to go check it out. It's kind of a slick tool to give you a bit of an orientation on what people are thinking on this really important topic.
Great. Next one is, I believe, on that book in the sort of campaign to get maybe disinformation out there, and they're asking, is there a way to assess how far the subversive diseducation sets us back or speeds up the detrimental practices?
I don't know.
Okay.
I would love to know that. And I might even pitch that question to our climate curriculum and instruction researchers to see if they've done any work on that. I do know that it is in certain states, there's a lot more action to get some of these misinformation campaigns infiltrated into school boards, infiltrated into state Department of Education policies. It's a growing problem. And so it's definitely not declining. It is on the rise, and it's something that we need to be concerned about and be actively looking for.
Next one sort of asks about comments on the new wetlands bill, and it seems like we might need more areas to handle flooding.
Yes, so that was one of the most important functions that wetlands have are with flood control and improving water quality. And so we already need wetlands, right? That is a part of our ecosystem. We need them already. And so when we look at future climate and it says more rainfall, more runoff, reduced water quality, particularly in winter and spring, we look to our wetlands to help us with that, right? We look to our soil health too. That's another challenge when we're talking about soil erosion, just more broadly. One of the best ways that farmers can help defend against excess moisture and moisture deficits is through really strong soil health, right? Really rich organic matter in your soil. Well, if that's all eroding away or decomposing really quickly because of high temperatures, the mechanism to buffer yourself on that is being degraded. So, oh man, that's a problem. Same thing goes with these wetlands. And so I'm not a policy person, but I know there has been a ton of discussion in the environmental world on just how dangerous that particular bill would be for our ability to handle not just our current climate, but our upcoming climate as well. So it's a concern. It's very concern.
All right, next one. What would be the one most important thing we can do as individuals to help slow this down?
Yeah, so I took out my slides in the interest of time on some of our individual actions on climate change. We put together a flyer. If you go to purdue.edu/climate and you go under the tab, I think it's Indiana or education, can't remember off the top of my head, scroll to the bottom, you'll find our flyer of what can I personally do about climate change. And we list out 4 things that are pretty effective. Because you think about it, this is a big global issue, and a lot of our carbon footprint we don't control. Okay, I flip on my light switch. I personally did not get to make the decision that, our whole grid here is running on coal or natural gas. I don't get to make myself personally decisions about investments in research and development on greener technologies, right? There's so much that we don't control about our own carbon footprint. That's the role of governments and big businesses and other things. But that doesn't get individuals off the hook, right? There are things we can do. Certainly, one of the most important things we can do is to be informed about climate change and how climate science works and climate issues, something all of you did here today. So keep learning about that. So knowing the basics is really important. Once you know the basics, another thing to do is knowing your own carbon footprint personally and changing what you can, right? So how do you use energy? How about your food waste? How about your transportation choices? And like I said, change what you can. I personally, I'm in the market for a new vehicle right now, and I was looking around it and I was like, oh, wouldn't I love to get an electric vehicle? Can't afford it. Just can't afford it. Shouldn't even feel bad about it, right? Like, yes, I want to do that, but it's not in the cards for our household, right? So I'm not going to tell you you need to be a vegetarian. I don't know what your dietary needs are, or your financial situation is for changing certain things. Change what you can, right? Find where your carbon footprint is and think about what makes the most sense for your lifestyle, for your household, for your current time in life. Okay. There's lots of options. So getting informed, knowing your carbon footprint and changing what you can, talking about climate change. Believe it or not, there is research that shows people who talk about climate change have greater awareness and greater concern and more willingness to act. Okay. So, talking about this with friends and family is a hugely important thing that we as individuals can do. And the research shows it can make a difference. All right. So, have those conversations. The more people are talking about it, the more they're prioritizing it, they're getting informed. And that is such a slow moving needle, but it needs to be happening, right? Very basic. People think, oh, that's silly. No, I tell you, that's important. And really, the last thing is active citizenship and climate leadership, right? Voting. Voting matters, whether we're talking about ballot boxes locally or nationally, or voting with our dollars on the types of businesses we support, and getting involved with climate leadership, right? Things in your social circle, at your place of worship, in your social clubs, at your place of business, if you're a business owner or something like that, supporting your own policies and budgets that are more climate friendly is really important. And it's an important way to help shifting some of those norms as well. So those are the 4 things we outlined. There's tons more, but I say start with those 4 and see where that gets you.
And can you say the website one more time?
Sure. If you go to purdue.edu/climate.
Perfect.
All
right.
Then you'll, yeah.
Let's see. I think we had one more. And if anyone needs to go, I've already dropped the link in for the LEU. But the last question we have here in the chat is, what do you think is the best thing we could do as individuals to help depoliticize climate change?
So
Just
when
similar,
we're
it sounds like.
kind of, but when we're talking about the need to talk about climate change, who is the messenger? That matters. Okay. And so if you can start getting people in a position of respect and power in a specific social circle to be talking about climate change, that's going to matter, right? If you're religious and in your religious organization, the person at the top starts talking about climate change, maybe some people who are skeptical might start to listen. Or if you're talking about, national security, having that head national security person might be the right audience. Those are folks that maybe we don't interact with on a day-to-day basis, but in our own communities, think about who are the thought leaders, who are the influencers, and can we get them having trust and partnerships with talking about climate change? That certainly will help depoliticize. Again, it's a slow moving needle. It's going to take time. It takes time to build relationships, but there is common ground, and focusing on solutions that have multiple benefits, right? Not just, oh, this is only for the climate and those things far away. No, let's think about what else happens if we clean up our, if we change our energy source, and what kind of air quality improvements do we see in our local community? Or we put in roundabouts and suddenly we make a dangerous intersection safer and more energy efficient, right? If we can start to rally around solutions that have multiple social benefits, you're going to bring more people to the table and start making some progress. So I wish I had better answers or more answers for you, but there's some starting points.
Sure. Well, other than that, we're getting a whole lot of thank yous and great presentations. So Lisa, you can go ahead and turn off the recording. And if there are any other